Hey everybody, welcome back. So we're finally going to dig into how you would get the time between a customer's orders. And it follows nicely from the work we've been doing using row number to get the order number for any given customer. So I've just reused quite a bit of what we've done earlier here. We have the payment ID, the customer ID, the payment date, and the order number that they've placed. So one means it is the first order. If you're not clear on how we got to this, just watch the last few videos and we kind of walk through how to put this all together and it'll make more sense. If you're ready to go, then let's go. So first thing I'm going to do here is we're going to use the lag function again. We saw that when we were generating random sales data using the generate series and random functions. But let's just kind of explore it a little bit. So just to kick things off, we'll say lag the date, so payment date, and we're going to do it over, I think, the customer. So we're going to want to partition on the customer and order by the date. This will make sense when you see it. We're going to call that prior order. And it worked. Okay. So let's see what we have here. So again, we're lagging the payment date over the customer partitions. And we're going in the order of the payment date. And, implicitly it is ascending. We'll just put ascending for immense clarity. And here's what I want you to notice. This value, guess what that value is? It's that value. This value is that value. So basically the prior order is the time of the previous order. And that's very useful to have. Now, on its own, this is not that useful, but once we start using it to calculate the difference of dates, then we can say how long it was since their prior order, and we can start answering more questions about behavior and timing. So let's leave that there, and let's take the difference of the payment date and the prior order. So here's how we would do that. We would say p.payment date minus this thing that we just wrote. So we'll just copy and paste it as time since. Let's see if that works. Whoops. Great. So we have something here. It's an interval. And an interval is not all that useful. You can see this is 17 hours, this is 1 day, this is 8 days. And let's just verify that this is true. So 8 days would mean that the difference between this order. So what are we saying here? We're saying the difference between this and this is 8 days, right? So March 1st and February 21st, the difference is indeed 8 days. Now, if you were to start analyzing this and plotting it out and looking at distributional data, your BI tool is probably not going to be happy about looking at data in the Postgres interval format. So let's just copy down this column and we're going to do something to it. We're going to, let me make some room here. We're going to extract, I think it's called the epoch from this entire field. And I believe that will give you seconds. Right, so here's the difference between the dates in seconds. And if you wanted to get that to, to minutes, you could divide by 60. Right, so let's just think about it critically, make sure the data looks right. So an order was placed on 2/15 around 1900. The prior order was placed on 2/15 around 1600. That's a difference of about 185 minutes. You can continue to tweak this to get minutes or hours or days, whatever you'd like, but at least now you have a consistently formatted column that you can use for your data analysis tool. And if you wanted to just round it, we could throw a floor on the calculation, I think, and it'll give us a better number. And let's call that, and you can, like, when the columns get really long, you can just, make a line break and indent it a little bit. Minute since prior order. Great, and now we're getting closer to answering our question of what the average delay is between the first and the second order. So let's clean this up a little bit. It's probably going to look like spaghetti code at this point, but it is working. How would we go about doing that? How would we get the time between the first and second order? Well, what orders do we not care about here? We don't care about the third order. We don't care about anything other than the first two orders. So let's just get rid of everything that's not the first or the second order. And we'll use our good friend the outer select, where t dot cust order rank, remember we're using this, is in 1 or 2. Okay, great. And really, we're just trying to take the average, right? So in a way, we don't really care about the first one. We don't want to take the nulls. So let's just put order rank is 2. Great. So now we have the second orders for every customer, and we have the minute since the prior. So really, all we would need to do is just take the average of this column, and then you would have your figure right there. The more interesting thing might be instead of a kind of linear average or something like that, maybe we want to take this data and break it out a little bit. So let me just wrap this up in a common table expression with our base table as, and let's look at it in the context of, just say we had this table and I wanted to look at the distribution of minutes since prior order. So I could say select all from BT, but really what I'm going to be interested, I'm going to be looking at a case statement. So I'm going to say case when BT min since prior order is less than, let's look at the data, say it's less than 100. Then we're going to say less than 100, and let's make a few more of these cases. Whoops, zoomed in a little bit there. Maybe that's easier to read for some people. Control D, copy it down a few times. Greater than 200, less than 200, then less than 200, less than 300, less than 300. And I'm not sure where this is going to go. We're just playing around with this, but you'll see where I'm going with that. My catch-all is going to be else greater than or equal to 500. I'm going to say and as time distribution. So let's just see, actually what we're going to need to do is we're breaking out this upper table now by this case analysis of it. We're going to need to do something with it. We're going to need to do a count to see how many people fall into what bucket. And then we're going to have to group by the case, which is going to be 1. So let's see if that works. Great. Now we have the roughly the time it took. It appears that most people are taking more than 500 minutes. So you might want to go back and rearrange these histograms. We can order by 2 ascending. But yeah, that's a good example of getting the base table, using lag to figure out what the prior order was for the customer. Again, we're partitioning by customer. And then we used extract epic, we divided by 60 to get the minute difference. We used floor just to keep the number from having too many spaces after the decimal. And then we used a common table expression to turn this into a table we could query from more easily. And we used a case statement around the difference in minutes to evaluate, how long is it taking most people to get from the first to the second order. And you can see that we didn't pick it too well. They're mostly bunched into this greater than 500 group, but you can do this however you like. So that's a great example of combining lots of different window functions, subqueries, case statements, and some other cool stuff. And now you're starting to get into queries that you'd probably actually be writing in the real world. Things you would write actually kind of look like this. So congrats if you're doing well. If you're a little bit confused, I would just urge you to keep watching it. It took me years to figure this stuff out. I didn't have any real good mentors or teaching aids available, so I had to figure it out myself. I paid people to help me with this stuff, and I practiced over and over. So don't feel bad if you're not getting it. This is a great reference. You're just getting used to these patterns, and it'll start to click, I promise.